You're alive. Don't know, I thought. The same thing I thought too.
Oh,
I mean, slides are going to be available. It's just it's weird.
so how are you going to switch it now?
You're asking me, I'm asking you. I know the technical. We'll have the slides afterwards. Slides are much like
It's good actually.
okay, so it's kind of online.
Yeah.
Hmm? Where's the mic? Let's check the mic.
So you can
Where's
step
the
outside.
mic? Yeah, you can just be
Check,
outside.
check. Check. Mic check. Mic check. Check. Mic.
Did you just check?
Check.
Who's the check?
Pizza cheddar. Okay.
Yeah,
We did. Okay. Give him the microphone.
we can give it.
Okay, good morning, everybody. You see, welcome to Andela. Thanks, Andela. My name is MJ. I'm the consulting coordinator here at Andela, so I work with the software developers. I'm welcoming you to this very exciting workshop. Please pardon my very silly behavior. I'm serious Mondays to Fridays, but Saturdays and Sundays, I really can't promise you anything. Today I'll just go through the housekeeping and I'll hand over to your wonderful facilitators. First things first, please put your phones on silent and turn them off from vibration mode because we're streaming live on YouTube and the vibration usually disturbs the recording. Also, we're going to hand out some sticky notes for you to jot down the questions for the end. So there's going to be a 20 to 30 minute Q&A session at the end of the day. Toilets are through this door, so if you need to use the toilets, they are through this door, and those are the doors on your right and left-hand side. The cleaners have said, please put the lid down when you're done with the toilet, because she doesn't want to come back and done cleaning on this floor. Also, we're not expecting any fire alarm testing, so if the fire alarm does go off, it's probably a real fire. Just follow me and Annie, and we'll direct you out of the building. We're very trained people. Like, I have debut on Disney Channel of firefighter. The internet is SOC2 guest, and the password is Andela _ 2017 if you haven't already connected to the internet. And if you want to tweet, Instagram, whatever you use, Facebook, about the workshop, the hashtag is Andela Workshop, and you can tag Andela Nigeria any tweets, which is Annie and Obito over here. Obito is stressed out. And before I turn over to these guys, I'm just going to tell you about the options here for you at Andela. So at Andela, if you're a software developer, you can come in through one of two pipelines. So you can come in either as a senior software developer, which means you have at least 4 years of software development experience. This link will be shared with you at the end of the day, as Annie here is a senior software developer at Andela, so you can answer any of the questions at the end of the workshop. After the technical bits, there's going to be food, so you can go back in with questions afterwards. Also, you can come in through the fellowship pipeline, which is for inexperienced developers. So you don't really need experience. Some sort of knowledge is needed for you to join the fellowship, but we provide all that through a home study path. And Obito here is one of our fellows, so you can answer any questions that you have at the end of the day. He's a superstar. He's the most senior apostle of all the fellows, and he will be taking the first part of the workshop, so please give him a round of applause.
All right, thank you, MJ, for that wonderful introduction. Don't mind how you just went to my head. Okay, thank you everyone for coming to this workshop. All right. So, in the year 2008, a man named Satoshi Nakamoto published a white paper titled Bitcoin, a peer-to-peer electronic cash system. The white paper is an academic report where inventors published in the US. Now, this system that Satoshi talked about was a system whereby you and I can transfer money to one another without use of any financial system like that. So, a year later, he developed the Bitcoin software in which the physical currency was produced. Now, nobody knows the identity of Satoshi. Some people believe that Satoshi is hiding due to the influence of the US government trying to handle that. Others believe that the name Satoshi is just an alias for a group of people. Now, before we try to ascertain what Satoshi was trying to solve, or what he really was, let's see what he was trying to solve. Now, in the world of businesses, where you and I operate, we are agree that there are so many challenges we face. One of those challenges is like maybe you want to buy a product. How can you tell that this product you want to buy is the real deal? You want to embark on a business. How can you ascertain that this business that you're going to embark on is worth investing in? You want to buy a piece of land. How can you be sure that this land you're buying, that the person selling the land to you is the real owner? Last week I was watching the news and I saw that an house agent sold an apartment to 18 people. As in 18 people, he collected money from all of them. How can you prevent that in the future? We a movie producer, you upload music to the internet. When you want somebody to buy your music, how can you be certain that when one person buys it, he alone will listen to it? How can you prevent piracy on the internet? We live in a world where there are so many deceits, cyber crimes, viruses, and now banks are getting hacked. So how can you believe the quality and integrity of information that you are getting? So all these things were the perceived confirmation that Satoshi presented in his white paper. And then how did he solve the solution? He created a technology that will someday that we allow us to business in a very good way. This technology was a single source of truth that was continuable, that was verifiable, that was tamper-proof, and most importantly, this technology was the field of human errors. This technology came to be known as the blockchain, aka Internet version 2. Okay. Okay, so my name is Ebuka Obi. I'm a software developer here at Andela. I write mostly JavaScript and security applications. For JavaScript, I'm a main stack. For those of you who know what the main stack is Mongo, React, Express, and Node, and as well React Native as well. So fun fact about me is I love coding. I'm not really sure if that's a fun fact because I'm supposed to be writing code, right? Then another fun fact is that I love watching sitcoms. Alright, so before we get started, if you have experience using blockchain, can I see your hand? If you have experience using blockchain, everybody. Okay, if you know of blockchain or this is your first time or friend attend a workshop, let me see your hand. If you know how to blockchain, let me see your hand. Alright, so if you never had a blockchain, that's different. Okay. So I just want to know my who I'm going to be speaking to. So what is a blockchain? Okay, before we go into blockchain, let us digress a bit to understand some basic terms in technology. What is the internet? Can anybody tell me what the internet is? Anybody? Yes.
The global system of data.
Good. Anybody? So we all know what an internet is, right? So the internet is the global system of interconnected computer network that use the internet protocol. So what this means is that each and every one of us here can connect to ourselves. We can share information within ourselves. You can hear and then you can interact with somebody else over overseas. So the internet is very important in our day-to-day activities. So banking. So to understand the basics of blockchain, we need to understand what the banking is because the blockchain is trying to emulate what the traditional banking is doing. Now, when you go into the bank, what does the bank offer that if you take that thing away from the bank is useless? What's that thing that the bank must do for you? Transactions, right? If you go to the bank and there are no transactions, I can claim that I have 1 million on my account and the bank will not verify it. So that transaction is known as the single source of truth I talked about earlier. Without that single source of truth, the bank is useless. So that's the same thing the same operation that the blockchain operates on. Now, what is a blockchain? A blockchain is a digital and decentralized ledger technology that records all transactions without the need for a financial intermediary like a bank. What is a decentralized system? Anybody knows about that? Anybody? So before we talk about decentralized, let us see what a centralized system means. A centralized system means that, okay, let me use the bank as a case study. In the bank is being controlled. There's an administrator that tells people what to do. It means that in a centralized system, an admin has the right to do whatever he wants to do. That's a centralized system. But in a decentralized system, for we to interact together, it means that we don't know each other. Anybody can interact with anybody and you trust that person because nobody has rules. There are no rules guiding you in that. Then a ledger means a record. Yes, like I talked about in the bank, there's a single source of truth. That record, if you want to know what you have, that record talks about everything you're doing. If you just 1 million today, when you come to know, the record says this is what I've done. You cannot change the ledger. Yeah, so that's what basically decentralized and the ledger means. So blockchain is eliminating the way we do traditional business. In the future, there will be system put in place for us to do business together without the banks. So how does the blockchain work? So on the blockchain network, when the transaction is initiated, so I have 10 bitcoins, and then you have 20 bitcoins, and I want to send bitcoins to you. That's when the transaction is initiated. Then there are people they call miners. As soon as that transaction is initiated, those miners, watch, don't talk about miners in the nearest slides. But just know that for now, these miners are the people that validate the transaction. And once the transaction has been validated, the block that is being created will be added to the list of blockchain. So think of evolution as a blockchain as ledger, as in blocks. So the last block, the ending block, is the last one. So whenever a new one is coming in, it's being appended to the last block. So if you come back, that one you just added now will be the newest one. And that's how you keep adding the blocks to the blockchain. So what is a node? Now, can anyone participate in the blockchain? Yes. And how do you participate? It's just by using your computer. Anybody can participate in the blockchain. And when you participate is what they call a node. So a node is simply a computer that participates in the blockchain network. That is basically you. So in the blockchain network, I told you that the blockchain network is a single source of truth and it's decentralized. It means that everybody has a record. In the bank, when you go to the bank only has a record of you. No other bank has that same record. But in this blockchain, everybody has that record. So I can come to you and see that record. I can come to another person and see that same record. So like I downloaded everything there. So if a hacker wants to hack the blockchain, it means that he has to go through the millions of all people that have that node in the system and hack 1% of them, which is almost impossible. So that's why the blockchain is very secure. So by keeping the shadow copy of that, so that three different kinds of nodes. Okay, there are three different kinds of nodes. We'll go into that, but nodes. Yeah, there's a right client which does. So when you participate, your computer determines the kind of node you're going to be. If you're going to use your normal computer, it means you're going to be having a shadow copy. But if you're going to use advanced copies, people that are into these nodes, this mind, they use advanced computers. So those are the ones that can go the full node. So what is a block? So a block contains this transaction. So when you initiate a transaction, when I transfer some Bitcoin to you, that block, it contains that transaction which can be recorded and kept. So when so that as the block contains the transaction, it appends to the blockchain. That's why it is a ledger, it keeps record of it. So a block contains transaction data and other important details related to the creation of the block, such as the time it was created and other unique information.
Hold on. So guys, while he's going through the slides, if you have any question, you could write it down, and after the session, we could take on these questions. So in case you have anything that is still confusing, just write down your questions, and after the session, on the questions. So that's what your secret are for. Thank you.
So a hash, when you store the block inside the blockchain, you don't just store it that way because anybody can read it. It is being hashed. I don't know if the developers know what the hash is. So a hash is a function that converts input of letters, numbers into an encrypted output. You don't just store the raw input there because anybody can read from it. So in the context of the cryptocurrency like Bitcoin, the transactions are taken as an input and going through a hash algorithm. So blockchain uses a cryptographic hash function, meaning that the output is random, but it's determined. It means that even if I hash it and store it there, the value of that hash will always be the same thing. So what's the transaction? We talked about transaction earlier. The blockchain transaction is defined as a small unit of task that is stored in public record. These records are actually group of blocks. A transaction is a transfer of Bitcoin value and broadcasted networks are created into blocks. So that's what I was talking about earlier. When you make a transaction, it stores that record for you. It's just like a bank, just like how the bank operates, but in the bank context, it's in a traditional way. This one is in the blockchain now. So we're going to take a video slide about hashing, how it works, how it functions, how you can convert hash, and we keep the value back. So I will give over to anyone to explain that video.
Okay, this video is giving you a context. You know, we've been explaining about the blockchain, the hashing, the mining. So we're going to watch a video by Mr. Anders. Mr. Anders gave a kind of visual explanation about the blockchain. And if you have your system, there is a link where we'll share, where you can see this actually online. He gave, as you can see, okay, this hash, blockchain distributed. He gave an example of how this can work. It's not exactly how it works, it's just like the layman understanding of how the blockchain is set up. So let us listen and see another view of the blockchain.
No, I don't think I need your mic. Good thing, right? Interesting. Have to go there.
Yeah.
This is a blockchain demo. We're going to do this in a very visual way, though. I'm going to make it very easy to understand by stepping through the key pieces of what a blockchain is in a visual way. But before we get started, we need to take a look at this thing that we call a SHA-256 hash. Okay, and a hash, this is one of them right here. A hash looks like a bunch of random numbers. And essentially what it is, it's a fingerprint of some digital data. And it just so happens it's the fingerprint of whatever I type in this box. So if I type my name, Anders, into this box, you see that the hash has changed. As a matter of fact, it changed every time I typed a letter, right? So I'm going to go back to this. So it says Anders. Okay, so this is the hash of the name Anders, all lowercase. It starts with 19EA, right? Okay, so if I delete that and I go again, type Anders again, you see it starts with 19EA, the same exact hash. In that sense, it's a digital fingerprint of this data. Whatever data is here, every time you type exactly the same data, you get exactly the same hash. And I can type anything I want. So you can have nothing, like this, E3B0, that's the hash of nothing. Or you can type tons and tons of stuff. As a matter of fact, you could put like the Library of Congress in here and you would get a hash. And the interesting thing about it is, regardless of if there's a tiny amount of information, no information, or the entire Library of Congress, you're always going to get a hash that is this long, this many characters. So you're not going to be able to pre-guess what this is. You kind of have to put the Library of Congress in here to figure out what the hash is. But you'll always get exactly the same hash regardless of how many times you put exactly the same information in. So what I'm going to do is extend this idea of a hash into something that we're going to call a block. All right, so let's take a look at a block. So this is a block. And it's exactly like the hash, it's just that data section I've broken out now into 3 sections. One called block, this is just some kind of a number, this is block number 1. A nonce, which is just yet another number, we'll go into what that is in a second. And then just some more data, just very similarly to the way that we had it before. However, the hash of this, which includes all of this information up here, is down here, and it begins with 4 zeros. You see that? That's a relatively unusual hash. Most of them are not really going to start with 4 zeros like that, but this one happens to. And because it does, totally arbitrarily, I'm going to say that this block is signed. Okay? So what would happen if I were to change any one piece of this information? Let's say if I were to type something here. right? The hash is going to change. And what's the chance of that if I type letters, this hash is going to start with 4 zeros? Pretty low, it's probably not, right? So let's see what happens when I do that. I'm just going to say, hi. Oh, look at that, right? This hash does not start with 4 zeros. And so the big background here is turned red. So now you know that this block with this information in it is not a valid or a signed block. Okay, and that's where this nonce comes in. This nonce is just a number that you can set to try to find a number that fits so that this hash starts with 4 zeros again. All right, so how do we do that? Well, let's start with 1. Does that start with, no, it's 3, 2, so that's not 1. So let's try 2, F, no, 3, 4, 5, 6. You get the idea. Like I could sit here, oh, there's one that starts with 0. I could sit here all day typing these numbers and trying to figure out one that actually is going to hash out to something that starts with 4 zeros. Gonna take a long time. So here I have my little mine button. I'm sure you've been wondering what happens if I press that. So what's gonna happen when I press this mine button is it's gonna run through all the numbers from 1 all the way up to try to find one where the hash starts with 4 zeros. And this process is called mining. Let's do it right now. Now it's checking all of the numbers from 1 all the way up there. Now it's stopped at 59,396, and that one just happens to hash out to something that starts with 4 zeros, and it satisfies my little definition of what a signed block is. Okay, so that's a block. Now, can you tell me what a blockchain is? It's probably just a chain of these blocks. Well, how do you put them together? Let's do that. All right, so here's my blockchain. I have block number 1. It has some kind of a nonce just like before. There's some data area to it, but then it has this previous here.
Okay, let me explain a little what he did before. What he did before was kind of explain what it means to hash something, right? So the very first demo he did, he was trying to explain that if you tamper with the information, you've altered the hash of that information. And that's one of the fundamentals of blockchain. Once something is tampered with, the trust in quotes of blockchain has been invalidated. All right. So it now goes beyond now to go into what the sequence. Remember, he was telling you about blocks. So that's where he's going into right now.
Here it's a bunch of zeros. Let's roll forward. So this is block 2 and block 3 and 4. This blockchain has 5 blocks on it, right? The previous here starts with 00, AE8, right? Is this number, AE8. And then this previous, B90 is this one over here, B90. So you can see that each block points backwards to the one before it. And remember that first block over here, there actually is no previous, so it's just a bunch of zeros. It's actually just a fake number. Okay, so just like we did before, what happens if I change some information? Right? It's going to change the hash of this block, and it's going to invalidate, right? Well, let's try that. So I'm going to try again. Sure enough, that block is invalid. All right, just as we assumed. But what would happen? I'm going to fix that now. Go back to something that worked. What would happen if I change something in this block? Right? It's going to change this hash, but this hash gets copied up to this previous. So it's gonna change this one too, right? So it should break both blocks. So let me try and sure enough, right? So we can go back as far as we want, to some point in the past and break that block, and it'll break all the blocks since then. Everything before is still green, but this one is red. So if I wanted to, change something in this blockchain, I could just go over to block number 5 right here. We could change it, and then we can remine it, and pick a different nonce. We'll do that right now, and we could essentially alter the chain. So we've done it, so we should be good, right? All right, well, what happens if I go back in time to here and I break it here? Now I have to mine this block, which will pick the nonce that makes this block hash out to 4 zeros, if we can find one. Sometimes it takes a while because it's got to run through a lot. And there it is. I found one at 138,000. All right, but this one's still broken because all those.
So let me pause it here. So what he's trying to say is, if you tamper with a block in the blockchain, it invalidates everything from that point down. And that's one of the bedrock, like I said, of the blockchain. The blockchain, like he said earlier, there's nodes scattered all over the globe. So if you want to go and tamper with someone's transaction, it means from that transaction that you tampered, you need to keep mining down. And you need to do that for almost every node on the planet. And you know, unless you're a super genius and you have one super computer that is running at the speed of light to be able to hack every node. So that's just what he's trying to explain about the blockchain. That every block has been mined and validated. Once you touch something somewhere, let's say you're feeling somebody's trying to hack into the system, someone touches it somewhere, it invalidates every other thing.
This one starts with 4 zeros. Adding the 4 zeros with different stuff up here still makes this block hash out incorrectly. So I also have to mine this block. All right? And that takes some amount of time. That one was a little bit quicker. And then I have to mine this block to fix it. All right, so what we're showing here is that if I go and change this last block, all I have to do is remine this block. If I go way back in time to back here and I make a change like that, I'm going to have to mine this one, this one, this one, and this one. So the more blocks that go by, the more blocks in the past that we are, the harder and harder and harder it is to make a change. And so that's how a blockchain is going to resist mutation, resist change. Okay, so now, like I did, if I do this in this block here, you can see that I've changed it to high and remined it, blah blah blah. How would I know that my blockchain? So now we have a distributed blockchain. It looks exactly like the last blockchain, up to 5, but this is peer A, the first peer. If we go down here, you can see here's peer B, and it happens to have an exact copy of the blockchain. There's actually also a peer C down here, and this could go on forever. There's many, many peers out on the internet that all have a complete copy of the blockchain. So in this case, if I look at this hash, it's 00E4B, right? If I go down to this one, I notice it also has E4B. If I go down to this last one, it has E4B, so they must be identical. And I'm going to demonstrate that by going here and typing something, and then I will remine this block. I've got some other number, and let's put some other number up here. So I should be able to mine this block. Okay, now all the chains are green, right? They're all green. However, this chain says the last hash is E4B. The bottom one says that too, E4B. And this middle one here says 4CAE. So I know just by glancing at this one little hash that something is wrong in this blockchain, even though all of the hashes start with 4 zeros. I know that this one is different. And it's different because I have 2, it's essentially 2 against 1. We're a little democracy here, right? This way.
Okay, so what he's trying to show here is that you change something on somebody's node, right? But what you've changed, you've mined it on that node. But there are other people who are keeping the same copy of the blockchain all over around the world. So if the other copies are saying one thing and your own copy is saying something else, that means yours is invalid.
for that transaction to be valid, every node on the internet has to validate that transaction. Like you said, a bank is the single source of truth. But in the blockchain, the single source of truth is everybody. Everybody has to agree that that transaction has taken place. So I am Eno. I sell some transaction to today. Now I sold $10 to Sunday on the blockchain. Now what the blockchain will do is it validates where it Eno get his own $10, right? It goes back. Who gave that person that $10? It goes back. So it goes back to the beginning, as long as how far it is. Now, I've given him $10. He now decides to spend that $10. Before it allows him to spend that $10, he validates who gave him that $10. You know, who gave him that $10? How did that person get that? That's how the blockchain essentially works. You can't come up one day and just have 1 million. There's no work like that in the blockchain. You have to trace where did that money come from? How did that transaction come to be? So this was just a small demo to show you a bit of an idea, in layman terms. This is not exactly how it works. For example, it wasn't leading with 4 zeros. It's just showing every blockchain that has an algorithm that they use to make sure that the hash follows that algorithm. So it was just giving an example that the hash must start with 4 zeros. It's not necessary that it will be 4 zeros on the blockchain. So I'll hand over back to Victor and let him continue.
So thank you for that wonderful presentation on hashing. So what is mining? Now, when a transaction has been initiated on the blockchain, the first thing that happens is that the Bitcoin software issues kind of it tells the miners. The miners, anybody can become a miner. Once you have a system, you have the Bitcoin software installed in your system, you can become a miner. Now, it tells this miner that, see, a transaction has been opened. Then this miner begins to mine. Mining means that you have to solve a kind of very advanced mathematical computation. This computation has something that they want to know what will be the value of the next hash. Remember, this money is all about adding the new block to the blockchain. So before this block can be added to the blockchain, the miners have to know what is the value of that block. So mining is the process of trying to, so in a basic term, it means randomly guessing. We are guessing. We are trying to guess what number will be fitting. But these kind of numbers are not just your 1 and 2 zeros. High numbers that are running into trillions of numbers. So the first person, remember, why these miners are mining? It takes roughly about 10 minutes for this for the value to be known. The first person that gets this challenge, the first person will become the winner of that transaction. Now, remember, at that point, there are so many miners working on that same transaction. Now, at that point, the person has found the answer. Other miners start validating the result of that mine. So you are doing 2 moves. At the first instance, everybody's competing. Once the first person has been found, other miners come and start validating if that result is true. So it's more of competition and cooperation, working together, solving this, and trying to know if this answer is right. Now, this type of validation is called proof of work. I think I'll show that in the next slide. But just know that as soon as the answer has been found, and other validators have validated that this is the answer, a new Bitcoin, that Bitcoin that validated, will now be added to the blockchain. And for that task, that miner that won that found the answer will be rewarded with 12.5 Bitcoin as his reward. And that is how Bitcoins are created. So, what's mining? So I just gave you a rough overview of what mining is. I'm still going to explain more details about it. Now, say it's a decentralized computational process that self-improves. So you create new coin. Like I said, the moment you find the answer and and that block is being added to the blockchain, it generates a Bitcoin. So there are Bitcoins in circulation. So that's how Bitcoins are being generated. The Nigerian banks in Nigeria still get generated in notes. In America, they generate their dollars. But in Bitcoin industry, this is how Bitcoins are being generated. So it creates new coin and then it converts this transaction as a means to add the existing block. Now, the problem with mining is that, yes, I said it's true that you can become a miner, you can have a computer and software. But the problem there is that it requires high power. As in, when I'm talking about power, I'm talking about power that lasts 24 hours. The upcoming said, I'll show you a factor of where miners operate. So it requires power and electricity, and then it requires internet, strong internet. Yeah, so say you can use a system as you want. So as you test case study, you can start with a system and as time goes on, you can build a system. So this is how a mining machine, that's the standard mining machine. In the factory, we have this kind of thing, 200 of it. It's called there. So it's called, so you can check this on Amazon. I think they said it's very cheap there. So this is a mining facility. You can see all these computers are being connected to themselves so that they can increase their power and be left this way. So the moment mining starts, the computer then compete on its own. So why I said that people are competing to know who becomes the first person, there are some factors that can hinder or that can support you to become the winner. So if your system, if my system is higher than your system, it's obvious that I am going to be the winner. If you have poor internet connection, so that's the factor. Another factor is the software you're using to run your money. It's not human. So why you are solving that mathematical problem, I think in the beginning, I think humans were not solving it, but now software do it. So you cannot be that kind of software. And for a software to win, it means that the kind of macro in the right is very, very essential. So I can have a good system, my system can be the best system, I can have the best network. But if my software is not very efficient. So, like I mentioned before, there's what we call proof of work. The moment, so it is validating transactions. The moment one of the miners finds the answer, other miners will come together to validate what this person is saying, whether it's true. So that is called proof of work. The other one is called proof of stake. This one has to do with the amount of coins you have in the blockchain. That's the second validation. So the history of the blockchain. So in the beginning of my workshop, I mentioned the system. So I talked about how Bitcoin was first conceptualized by a person named Satoshi Nakamoto. So it was just him trying to envision a system whereby you don't have to go through the hassle of banking system to achieve the transaction. So why was it invented? So I talked about why it was invented. The problem of traditional banking system. What we face when we want to get into the bank. So if I want to transfer something to you, I don't need bank. I just try to pay this some amount of time. So validation of transactions, like I mentioned before, the miners will do your transactions for you. Without any problem trying to validate for you. So for me to sell the transactions, for me to sell the Bitcoin to you, blockchain will trace who sold that one to me, who sold it back to the origin. So you can't just come and any block in the blockchain and you feel that you are safe. It's a question of powers. That one is the explanation. So version of blockchain. The first version was by Satoshi Nakamoto. The second version was by Ethereum, by Vitalik. And the third one is by the killer. This one's are the new ones. So types of blockchain. We have the public blockchain. This blockchain is fully decentralized. Remember what I told you about something becomes decentralized. This everybody have power to it. Anybody that you don't trust can add to it. So that's what we call public blockchain. In this one, it is limited to a certain kind of people. Don't allow us to get this after the workshop. So this one is limited to a certain kind of people. It's not everybody that participates in this one. In the private one, it's private. I mean, only the people that want about this blockchain are the one that can mine it. Cryptocurrency. So I talked about cryptocurrency. I talked about one cryptocurrency called Bitcoin. So so the blockchain is the platform. I told you that the blockchain is internet version 2. So blockchain, the Bitcoins are the currencies that are used for daily transactions. There are other ones of which we're going to see next. So there are 3 types of there's one that operates on the blockchain, there's one that operates on Ethereum. Or I will explain Ethereum in the upcoming slides. And they have altcoins. Altcoins are being derived from coins. So how many cryptocurrencies are out there? There are about 1,300. About Bitcoin is coin. The next chapter is Ethereum. So this is a table that shows the top cryptocurrencies in the world, their market caps. So as you can see, for Bitcoin, the one Bitcoin is 6,000. In fact, I checked this morning, it was $6,500, just one Bitcoin. Yes. So imagine that you've been awarded 12.5 Bitcoin. How much is that? Is that explain? Yes. Imagine you're being awarded 12.5 Bitcoin. What will you do with it? So for Bitcoin, this is what's circulating now. 17 million Bitcoin. But it's estimated that 21, the cap for Bitcoin is 21 million. So for Ethereum, the cap should be 120 million. But for now, they are working on 100 now. What Ethereum is 562. So these are the ones that are there. These are the top ones. You can make research and get data. So applications of blockchain. Yes, people are studying blockchain, even though the technology is still new. Can use it in healthcare. These are some of the websites that are speaking for blockchains. One is in the healthcare. They keep confidentiality of their patients so that they don't just access it. You know, there's a problem in the US against the rule to check your patient's records. Blockchain can lead to that third party, financial system, and then retail. And then in real estate, in transport and tourism, and in media. So you get this advice and go through it. Ethereum. Before I talk about Ethereum, when Satoshi Nakamoto discovered Bitcoin, Satoshi only made Bitcoin available for just the money's sake. As in, when he was creating Bitcoin, so just how do I make it money? He was talking about money. But as time goes on, people then began to realize that there is more to blockchain than just Bitcoin. People realize that you can use the original technology of Bitcoin for not just currency, but you can use it to create other applications as well. So one particular person, I think Vitalik, he was an translator at that time. He wrote a white paper that Bitcoin is good, but it's very simple. It's very simple edition. Why can't we make something more complex? So Vitalik was eventually something that you can use blockchain to do apart from just Bitcoin. So that's how we created Ethereum. He was the co-founder, and they created Ethereum. And Ethereum is a network that runs on the blockchain. So now, after Vitalik has made that white paper, it became known. And then, with that Ethereum, they could not create complex application there. In fact, you could create cryptocurrency on Ethereum. You could create domain system on Ethereum. You could create gambling system, gaming system. It then became wide. Now, inside Ethereum network, there was a technology called smart contract inside there. The smart contract is just kind of a piece of code that is the core of Ethereum. It is what makes Ethereum what it is. Smart contracts are just there, whereby you send them message and they act upon what you tell them to do. So that's how Ethereum came to be. And ever since Ethereum came out, the currency for Ethereum was Ether. And right now, Ethereum is getting popularity. So blockchain. So when people hear of blockchain, the first thing they hear of is Bitcoin. So Bitcoin is just the minute thing you can do on blockchain. So I think that should be what you should learn today. Most people think they are the same thing. Just like saying you want to do email on the internet. It's email that you can do on the internet. You can do so many things, right? So Ethereum is a decentralized platform that runs smart contracts. Smart contracts is the core of Ethereum. Look into smart contracts. I think in this workshop, we look at what smart contracts are about, how you can write applications with smart contracts, and write applications in Solidity. But if you've never used Solidity before, it's quite easy. So the mission of Ethereum is just created by Peter. So you go to the white paper on decentralized applications, announced 2014, and then it's currently supporting 100 million data decentralization. Components with Ethereum. Ethereum is a cryptocurrency which technology is invented by Ethereum. So these are the mostly components that composes of the Ethereum. You have Ethereum on which it runs, then you have smart contracts. The smart contract is, like I said before, is a program that's running on the Ethereum. Now, let me give you a kind of practical application of the smart contract. So while I was learning blockchain, I started writing smart contract application. I was building an application whereby, so before it's a platform, so before you can rent an apartment, you have to go online to check if that apartment is truly what it is. So how I built the application is to check who was the tenant before them. To go back and know who the tenant before them. So that when someone tells you to pay, you check and know if that person is worth it. So the admin issues an instruction to the application and say, hey, this application for me, this contract for me. And then once that been created, if the person on part A, as in buy side, fails to meet the application, the contract will be null. So remember, where it was created, it is not the admin. Remember, it's not the admin that creates the contract. The admin only issues instructions to the application to create the contract. So once that contract has been created, it's there. Your normal conditional application, when you want to create this kind of application, you create a website where the admin uploads all this kind of thing. But the admin can get hacked, and so the contract can be changed. But this name now, it cannot be changed. It's a contract. So this is basically a diagram of how it works, of how money is being transferred, and how all these things here are what goes into the contract. So I'm going to put this again. A smart contract is similar to a contract in the physical world, but it's digital and it's represented by a tiny computer program stored in the blockchain. So that's what it is. It's a piece of program that sits in the blockchain. And then it's acts like as if you are like a lawyer. If you fail to meet your obligation, you cancel the contract. So this is how smart contract works. So this is someone that is trying to sell a house. This is someone that is trying to buy a house. And so this everything here is included in the blockchain, in the contract register. And then if any of them, if anybody has transferred the contract obligation, then issue the transaction. So this is smart contract, but in this case, let's take someone that will upload music to the internet or people to buy. This person also wants anybody, like today you can go anything from the internet. You can download music and play. This person doesn't want it. The one that before you can listen to his music, but he must have purchased it. So you upload the music to the blockchain network, and it passes through all the stages. So you, user, before you can access it, this blockchain must have confirmed that you bought it. So if you go through this, you see the stages being passed through. So with this process, you can't cheat the system. Yes, when blockchain are coming forth in the future, this is the process that you pass through. So if you're a musician that's complaining of piracy, the blockchain will help. So what's blockchain better? Why do people want to invest in blockchain? Trust. Like I told you, blockchain is a single source of truth. If there's nothing you can grab from the definition of blockchain, just remember that it's a single source of truth that is untampered, unchangeable, verifiable, with the end of human errors. So when someone is operating on the blockchain network, you should be having trust in that person. It's safe and it's accurate. So what are the concerns of blockchain? We have heard of blockchain. Why is it not being used now? What are the purposes of it? So, bam. Some countries know that use of blockchain in their country will disrupt social and economic activities. That's what some countries want it. It's expensive to run blockchain. Yes, blockchain is the internet version too. On the normal internet, you can go to any website and do whatever you want. But on the blockchain network, it's quite expensive. To make a request, you be charged. Yes, just like how you do your normal browsing. On the blockchain network, you get charged for it, so it's quite expensive. Then people fear that it's a bubble burst. People think that it's my business MMM. It's highly volatile. So the currencies are highly volatile and it's not for the faint-hearted. It's for people that have the mind to invest in it. Another concern that it's kind of complex. Just like you are today, you are trying to learn about it. Most people don't understand what is under the hood of the blockchain network. Then it is slow and cumbersome. Yes, I'm saying to you, I'm not really saying that blockchain is fast. For you to initiate the transaction and complete it takes roughly about 10 minutes. I mentioned it earlier. So it's very slow, especially if you don't have a good network. The invested interest. So many people are not going to buy anything now. So if you want to invest in it, you might not get good sponsors for it. Why should I care? So this is a chart from the Q1 of 2018. Yeah, we just do research for Q2 and Q3, but I don't think we know out yet. But for Q1, this is the top skills that are needed. So if you don't have these skills, it's going to change. You have blockchain as the first one, of which you are having the workshop. So can I get started? Can I start with blockchain technology or only currency? Can we start with technology? Can we start with blockchain? Yes, you can start it. It's not very hard. So these are the things. You need to do to get started with the blockchain. You need to learn the programming language. I talked about solidity. I'm not familiar with JavaScript applications. So that's one. So you need the community. You need the code to look for one. You need to get finance on board. You can't just start it without finance. People need to validate the transactions. You need to know your wishes, then develop your own one. So these are the referrals.
Let's go back to that slide. No. Okay. For you to either own a blockchain or be part of the blockchain, you need to do any of this. Now, what we've just done today is what he has just done is like an introduction into understanding the concept of blockchain. What I will be going into is developing a blockchain, and that's one part which is solidity. Programming in blockchain is fast. We have people that use Python, we have people that use Ruby, we have people that use JavaScript, React, and all that. Now, if you want to start your own blockchain technology, that's why I came back a bit so that I can really emphasize this. We have lots of people who are so good in writing, hashing, and algorithms. But why some of the blockchain coins and infrastructure are failing? Because most of the people that go there, they don't go there so that they can make big money and come out. That's not what the blockchain is about. You need to have what we call your community. People who have the same ideology with you, who feel blockchain should do this for me. And you have to grow that community so that by the time you launch your own blockchain, you have a followership. So that it's not when you have launched your blockchain, you now start looking for people to join your team. Don't limit yourself. Another thing that stops blockchain, some of these coins they don't last is because they don't get enough miners. Remember, for a transaction to be validated, miners have to mine. And mining is not a small task. Mining requires your system, your internet, your power. You, just in Nigeria here, you don't really pay for power like that. When I say you don't really pay for power, in some countries, the more you're using power, you are paying. It's not here that they do some assumption fee and give to you. Then your internet must be wonderful, your system must be high speed. And the guys that do this mining, they are forever always trying to chunk out system. Okay, can you open, go to Google so that we can show them an example of some transactions that are going on online. Search for unconfirmed transactions. Yes, unconfirmed transactions. Unconfirmed transactions use content or blockchain. No, that's YouTube. Can you go to your browser? Yeah. Yes. Yeah, click on that first. Nothing can be. So, if you look here, transactions are happening right now on the blockchain per second. And it's the miners that go here and pick up a transaction and validate a transaction. And remember, a transaction, for it to be validated, it will validate each block that is preceding each block. So if you go to this site, as of last night, it was about 22,000 unconfirmed transactions. It keeps updating. Sometimes it increases, it reduces. So these are live transactions that are going on right now. If you look at the time there, that's 11. These transactions are happening as we are speaking. People are working on the blockchain. And miners are picking up this thing. The first person that can confirm any of these transactions gets a value. So your miners, if you go back to us, like I was saying before, your miners have to have vested interest in your blockchain for your blockchain currency to survive. So you remember he spoke about proof of work and proof of stake. Proof of work is this. The miners, the first person that validates this transaction gets that percentage. You know that you do a transaction in the bank right now, they charge you 100 depending on the transaction. But in blockchain, the person that successfully validated that transaction is the first person that will get that money. So mining is not is a business on its own. The blockchain is a business. There's so many ways you can tap into what this blockchain can do. So I just wanted to just show that part before you.
Yes, thank you for that quick explanation. So these are most of the referrals that the always able to use the blockchain. You can about them in your time space. Yeah, so that concludes the end of the session, and I hope that everything I've got today are just the basics of blockchain. Yeah, so after today, you should be able to know the application of this, where you can use it, and how you can tap into it. So I can't wait to see what you do with it. Thank you.
So the next session we are going into right now is we're going to start writing in Solid. I hope you came with the systems. Yes, the workshop. Just come with the system. Also come with the system. So we've talked about blockchain. Let's write some simple smart contract. I wish we have more time. But as we are writing, I'll be explaining what each section is doing, how what solidity is all about, how you can apply it. We're going to try, I was hoping we'd be able to do a voting system, a lottery system, a messaging system. So while they're trying to get this off, does anybody have any questions about the previous slide? Okay, you're writing yours down. Okay. Okay.
Good morning, everybody. My name is Bala Michael. The first question, the miners fee was measuring 12 point something BTC the other time. I want to know if the amount is fixed and if it's not, how is it calculated? Then you were talking about the security of Bitcoin. Sometimes around last year, there were cases of double spending. So I want you to throw more light on that. How was they able to manipulate that? Thank you.
Okay, first of all, on the blockchain, there is no fixed amount for a transaction. It's on a percentage level. So depending on, I can come up with my own blockchain today, and I say that for every miner, they must get 0.0001 value, right? That is what I have put as a law on my own blockchain. Another person on the blockchain can decide to say that no, it should take 0.5% of the value of that transaction. So it is defined by the owner of the transaction. It's not like CBN that has a fixed value overall. Right? Now for the double spending, I don't think that happened on Bitcoin. I think it happened on a platform that was using the Bitcoin. Now, just like I'm going to explain now, if you're using Solidity to build your application, and there's one thing about the blockchain, once you build your application and you deploy on the blockchain, it's done. Unlike the conventional applications online, they will release a new version maybe to fix that issue. On blockchain, it doesn't work like that. You have to drop that smart contract, disable it, and put a new one. So the guys that built that probably did not have a full understanding, or they did not debug the application properly. So when building smart contracts, you have to test thoroughly, and it's one of the things I'm going to talk about. You have to test thoroughly and make sure it is done properly. Because once it's out there, it's out there. There's nothing like, okay, let me write a patch to fix it. You bring it down and you push something else. Some guys are bringing out something that can be used to update a smart contract. But the strength of the blockchain is whatever you put there cannot be changed. Do you get it? So the onus is on you when you're building your applications to make sure that these things are totally running smoothly. And if there's an upgrade, I'll come to. I don't want to go so deep into that yet because this is a new session for those who are understanding blockchain. But as we go advanced, I'm going to do a series. We're going to go into how you can update some of these your applications. Because the question you will now ask is, so are you saying that when I build an application, it's there and I now have made a mistake, can't change it? We'll answer that question. Right? Now, what if the last block that is tampered with, can the hacker be successful? Let me say it again. If you touch anything on the blockchain, they have invalidated that block. And for a hacker to successfully tamper with something, whether it is the last block or semi-last block or the last before the last block, he has to do it on every node in the planet. So, assuming my system now is on the blockchain, that person has to find a way to get into my system and change my copy. Let me make you understand it that way. So, meaning everybody that has a copy of the blockchain, because that is what it's all about, is a decentralized system. Whoever is hacking has to hack everybody's system at the same time. Whether it's the last transaction or semi-last transaction, at the same time. And like you see what is going on, right? When I showed you, transactions are happening. So just indulge me a bit. The person is trying to change the last transaction. And remember, other transactions are depending on it, right? So he has to do it on every system, do it at that same time, and make sure that other transactions that are following validate that that other one is okay. And I'm sorry to say, you might just have to be God to be able to do it. It's that complex. Because once you touch one transaction, other transactions are being validated against that last transaction. I hope I answered the person's question. Does every cryptocurrency has its own blockchain on node? Yes. Most of the cryptocurrencies you see, that's why we have about 1,300. But it's not all of them that are functioning at the peak. That's why he said Bitcoin is king. I'm trying to go as fast as possible so that we can start the development. You said everybody can see it and can't be hacked. Are you saying our transaction is not confidential? Okay. This is another aspect that your transactions are confidential, but they are public. Nobody knows that hash belongs to you. Your name is not there. It's just your address. But what's happening right now is that the banks are trying to form a consortium. There's a blockchain called Koro. There's another one called Koda. These two, what they do is they form, like remember when I was presenting that we have public blockchain, which is the Ethereum and the Bitcoin, and we have private. In fact, some of these privates, the FBIs of the US are seeing them as being used to all these underground covert operations, all these drug deals and all that. But the banks have come up with something that they can validate each other's transaction in a way. So it's called Koro. It's by JP Morgan. There's another one called Koda. So these two are trying to answer that question that you're talking about, where transaction is not really public, but it's public within the banking system. So that somebody cannot just say he has 10 million naira in another bank. This other bank can easily validate that you don't have that 10 million. Do you understand? Okay. How are these mathematical equations solved in mining? You have to be a crypto experts. They have all kinds of equations are put into their formula too. That's why when you're building your own blockchain, you must have a group of people that are very good in cryptography. You must be very good. So that whatever you are putting out there cannot be hacked. If not, people see you as a fraudster. Does this mean that you can control the system from a node? Never. You can't. Only be part of the system. Now, there's even something you didn't mention. There are some softwares you can download on your Windows. I'm trying to find the one for Mac. There are softwares on Windows that can make your system a node and you can earn money. So as far as your system is idle, not doing anything, you can put on that software and your system will be generating money for you. It all depends on how fast your system is, how fast your internet is, determine how much you earn. I don't know, did you show them the slide of the mining facility? Those people that are into the business of mining, what they did is that they created a warehouse where you can just put your stuff there. A warehouse of mining machines. Because ideally, truly speaking, those mining machines, to actually make some serious money, actually, those systems has to be quite much. If you install the wind miner on your system, you see what I'm talking about. It might take you a whole day to mine about $0.02 because of the way your system is and your internet. So, you can imagine why those guys are putting that kind of number of systems. And those systems, trust me, they are way better than the best laptop you have. The minimum those mining machines can have is 16 gig, 32 gig, and thereabouts. And they are running at unbelievable speed. Because for you to validate the transaction, like I said, you know how long it's going to trace to the beginning of the blockchain. Every validation, every single transaction is being validated. So let me try and round up these questions. If a block can be found in different nodes across, does that not imply the data is prone to hacking? I just answered that. Since once a node is affected, it invalidates the blockchain in the system. Then does that not mean you are still faced with the same problem? That's what I'm saying. Once we have assuming we have 1 million nodes, then you managed in your superhuman way, managed to hack one node, and the other 919 are saying something else. Who are we going to believe? Do your one node or the other? So that's that. And but for you to even have one, I'm not saying it's impossible, but just make sure that you have the light speed. And I'm not sure they build those kind of systems that can do that throughout the whole nodes. What difference between blockchain technology and trading? There are two different things. Right? Trading is a whole, and you see trading in Java, you see it in .NET. Trading is sending different kinds of processes to be happening at the same time. Blockchain follows similar paths, but they are not the same thing. They are totally two different concepts. What's the role of blockchain algorithm in app development? I'll leave this question for later. Does this mean that you can control the system from the node? Okay. So, as the system Okay, can we split this so that it's not showing exactly what it is? Extend it.
Okay.
While they are working on that, for those that have your system, they're going to be working with Solidity. So, if you have your Chrome browser, go to metamax.io. and also Truffle, Truffle. I want us to have got the time on our side. I want us to really do as much as we can. There's a site called truffleframework.com. So open it on different tabs so that we can move as fast as possible. Come again? Okay, metamask.io, metamask.io. metamask.io. So basically, we're going to play around building an application in Ethereum. So as okay.
Can I grab something? Is your please? Trust me. Just remove it.
All right, I'm going to open. Yes,
So it's pretty. Okay. Don't touch it.
So if you send this, you see this down here. Truffle framework is called. So these are some of the tools we use for building smart contracts. Right? We're going to download Truffle, we're going to download Pinache. You can click on that GitHub repo there to take you here. Another thing we'll need is Node. So do you have Node on your system? For those who develop in JavaScript. All right, let's just start with the presentation and we'll take it from there. All right. My name is Andela. I'm civil technical consultant at Andela. I develop in Python, C#, PHP, Ruby, and Solidity. I'm a drama director. I love animes. I play basketball. I'm a football analyst. Sometimes you see me on Super Sports making some analyst contribution to the cause of Arsenal and Arsenal fan. Sorry, not words. Okay, so this is basically what we'll be looking at. What you can do today with Ethereum, understanding DApp. Do you know what DApp is? It's decentralized applications, web applications versus DApp. What does that mean? Ethereum nodes, Ether determinations, using MetaMask and all that. I wish everybody here was using a Mac because most of the things I will be doing here will be on a Mac. But let's see how best we can go with this. So we are going to go deeply into Ethereum this time around. What can you do today with Ethereum and dApps? Basically, you can send and receive Ether. Now, remember, every Bitcoin has the name for their own money. Sorry, every blockchain, right? Bitcoin has its own name, Bitcoin. Ethereum has Ether. And all those lists you saw there have their own names they call their own coin. But in Ethereum, you can see that we'll be able to do what send and receive data. We'll be able to write smart contracts. We're able to create provable fair applications. You launch your own token based on Ether, meaning that you can do your own blockchain technology. Then we also bring the promise of decentralized databases. That's basically a summary of what you can do with Ethereum. So what is a DApp? A DApp is a decentralized application. It's a peer-to-peer solution. Data is shared, code is shared. Once you're on the DApp network, or that which is Ethereum, all this applies. Now, basically, this is what we know as a web application. A user goes to the browser. From there, you have your front end. If you're aware of what technology is all about, your front end talks to your back end, Python, JavaScript, Ruby, and all that, and interfaces with the database, right? You're all aware of this kind of architecture. But in that, you have your browser and your front end and your network. You have your network. Your network is your database, is your server code, is your everything. That's how it works on the Ethereum network. So, on the network, Ethereum network, we have what we call EVMs. This is what is running your code. This is what is running the network. A question? Sorry? Okay. So this was running your network. So think of EVM as the runtime for Ethereum network. You've heard of Java runtime. Have you heard of that? That runs your Java code. Just think this is exactly something like that. Now, mining nodes refer to the nodes that belongs to the miners. Now, even though we have our normal nodes, we still have those nodes that are used for mining. So these are the concepts that are in Ethereum. That is what we're looking at. Now, basically, for developers, which I hope is what you want to be, you have to connect to a framework what we call Web3.js to be able to connect to the Ethereum network. It's like a library. I'm sure you guys have been working with libraries for those who have been developing. So you interface with this library to be able to push your application to the node network, to the Ethereum network, sorry. For consumers, we use what we call MetaMask and Mist browser to be handling and managing your Bitcoin, Ether, and all that. So what are the types of transactions we can do in Ethereum? We can do transfer of Ether from one account to the other. You can do deployment of smart contracts. Once you are invoking a function within a contract, that's a transaction. All right. Unlike other transactions that you do online, or imagine you're going to okay, for those that were not here earlier when the screen was shown, the Wi-Fi name is SOC2 guest. SOC2 guest. For those that came late, and the password is capital A ND 3L at _ 2017. I'll call it again. Capital A ND number 3 L at, that's the at sign, _ 2017. So for those trying to connect to the net. Now, it's pretty expensive to run an application on the Ethereum network. So it's not a you want to go and browse, just like browsing there and checking one thing and the other. Every function that is being called on the Ethereum network needs you to spend some amount of money or some amount of Ether So even a small function as retrieving a user list or user information, you are consuming Ether, you're consuming money. Yeah, you begin to ask, so if I want to build something like Twitter on Ethereum, I mean, man, just think of just for your users to be, imagine you build an application and for your user to Facebook on your application, example, just for them to see their image, they are spending money for what now? But by the time we go deep into this journey of blockchain, you'll find out that probably not all those kind of fancy applications can come on the blockchain. Maybe, maybe not. But the blockchain is serious business. I hope we'll be able to open that MetaMask that I said earlier for those that have the system. All right, I'll go to the slide and to the browser now. Skip this. And MetaMask. For those of you with your system here, see. How many of you saw this on your screen? So we are going to get that Chrome extension. Do you have it on your system? Okay, so I'm trying to find it. If you can click on this link here, get Chrome extension. So just run through the whole process so that you can get to where I am. Can I see your icon? Okay, right. So are we all done? It shouldn't take you so long. It's not a big application. Okay, so add to Chrome. Add extension. Yeah, so you can see that it's been added there on top. So you click on it. Try it. There's a new version. Text new later. You can try it now. So you accept. Accept. Read through. Accept. So hold on. So here you're going to enter your. How many of you have done this already? Enter your password. So you can enter your password. So what this will do for you after entering your password is to generate a 12-word mnemonic. This is what is going to handle your accounts that you have on this plugin MetaMask. Just you can use the password quickly. Minimum of 80. Yes. Hope you remember it. Yes. Okay. Confirm. It's not going. So that's 4. That's 5. 6. 7. 8. So click on create. Okay. You need to copy that somewhere. Keep this safe somewhere.
Okay, I just download it.
Yes, download it. Yeah. You can also download it. No, go ahead. You are not done. Just click on and copy this somewhere. So what this gives you is like an interface that you can use to either work on the main Ethereum blockchain or some other networks. If you scroll up there, click on that main network tab there, you see the networks that you can work with Ethereum. This is like your local system, and this is the custom one that you might want to work with. This one comes, these are networks that you can use to test before you deploy. Remember, I said you must work and make sure your application is working fine. Perfect. That's the word, not even fine. Perfect before you deploy. So these are the networks that you're going to use before you deploy. These are the ones that you're going to use on your system. You know, when you develop your system, you want to test your system before you develop to a test server, then your test network. So you can click it to close. Yeah, so and you have some accounts. You can click that circle there. It gives you, no, go top there, top, circle. Yeah, click on there. You see you have, it gives you a default account. You can also add some other accounts there. Now we are going to do a small exercise. Go to Google and type ring B faucet. For those that have the system, you can also do it here. Type ring, I can't remember the URL right now. So that's ring, R-I-N-K.
R-I-N-K.
Yes. R-I-N-K-E-D. Yeah, go down. Go to that. So the site that will allow you to add, yes. Okay. This site allows you to add it to your account. So what this site does is that before they can allow you to add Ether, because they know that some people like to be so very fraudulent. So what you do is paste that to your account, go to that MetaMask. I'm trying so that we can run very fast. Let's go to the plugin. Go to copy address to clipboard. So what RingB wants is that you copy your address and paste it on a social media link, and copy that link and go and paste it in that place and ask for some Ether, so they'll give you some Ether. So what we're going to do is go to plus.google.com. Okay, we're going to create a new post. Sign in. Should be assigned for a new post. Click on home. No. Click on home. Yes, click on home. Yeah, click on that button. That's what I'm looking for. Okay, so paste your address there and post. Are you guys following? All right, so you see that you have this new. So can you copy the link? So copy the link from the address bar. All right, then go to RingB, paste it there. Then select give me Ether. And select 18. Yeah. So if you go back to click on MetaMask up there, you don't need to go back to that tab. Just go to Yes, please do. Okay, take some time. No, you're on the main network. Change your network. Go to really, yes. Yeah. So this is just for testing because you're going to use it to do a lot of tests and all that. I think this workshop, honestly, should be the whole day, but we'll try. Let's see. Okay, so now we have some detail on stuff. We're going to start writing smart contracts. Okay, so where are we? From the beginning. All right, can we go to MetaMask? For those that did not install MetaMask, go to metamask.io. Are you there?
You have the demos. Where is it?
No, don't worry. We're going to start all over so that everybody is on the same page. I hope we're using the network here. That was very fast. I believe everybody here is up to this point. You have some internet. Those that have their system.
Yeah, you.
So, okay, you are back to MetaMask, right? Okay, no worry. We are still going that same route. We're coming back, right?
Have you been Google this?
So, have you installed MetaMask on your system? You are fine. So, are you fine over there? You are fine with MetaMask. So, you have your account. Keep going on. I want to make sure we're all on the same page as MetaMask. So you have your account now. You have your account. You have your account. Right? You can see the account one. All this. I hope you copied and saved your 12 words. So we're all on MetaMask, right? Hello. Okay, good. So now click here and copy your account address. Now on Ethereum, that is your address. That is like your account number. Hello. Your address is like your account number on the Ethereum network. So have you copied? Have you copied? Have you copied? For those who were behind, I'm trying to bring you up to speed. Have you copied the address? Hello? You've copied. Now go to plus.google.com. At least I can always do one exam. Have you got to plus.google.com? Plus.google.com. Are you there? You're logged in, right? Go to your home page and create a new post. Create a new post and paste that your address there. Are we on the same page there too? So I'm waiting for you. Click on your home. There's a button there, home. Now click on that red button there. Good. Now paste your address. Paste your address there. Control V and post. Alright, so we have a new post here. Now at the top right, you see one box there. Click there to copy your link. Or click to go there. Whichever one. Alright? So, have you clicked on it? Have you gotten the address of that post? Hello? The guy that said you were stuck at plus. Are we together now? Have you gotten the address? Now, on a different tab, search for ring B. Okay, already have it. Now paste it there. And take it later. Don't select it. Good. So click on your other icon. Select it. Bring the test network. So I believe we are all on the same page now. Are we on the same page now? We've gotten the money now. Give me that. Go to MetaMask. Select Bring B Test Network. We need to move very fast. We're already behind. I want us to do a smart contract today, like a hello world. Then we are done. But I need to explain a lot of concepts for you. So I need us to move very fast. Okay? Okay? All right. Now, back to our slides. We have what makes a transaction. In most of all the blockchain, you'll see something like this. And this is for Ethereum only. For now, you see the from, you see the to. That's in a transaction block. What makes a transaction block itself is this component. From, it denotes the account of the receiving conjugating transaction. It's coming from Mr. A to Mr. B. The value, this block hash. Remember what we did in the first session, where if you touch anything, that hash is invalidated. The block hash, the block number, the gas price. For your transaction to even happen, you must pay a gas. I'm going to come back to that. For you to drive your car from here to Ojelegba, you are consuming gas. And you are willing to pay a certain amount per gas. So that's what this whole concept is about, gas price. Like I said, we'll do a series after this so that we can go into all these concepts in detail. So just follow me. So this is the hash of the transaction. This is the hash of the block that this transaction belongs to. This is a number called nonce. It's just like the number of times this person has been doing this transaction. The transaction index, the serial number of the transaction in the block. And the VRS, this is a digital signature assigning of transaction in cryptographic pieces of data. Let's move forward. This is a block also. The other one was a transaction, this is a block. So a block consists of all this. The gas limit, the gas use, the miner, the number, the parent hash, the nonce and the transactions, and the total difficulty of the chain of this block. Can we go ahead? So Ether is the currency of Ethereum. All right? Every activity on Ethereum that modifies a state, the Ethereum has a state. So anything that changes the state, meaning that something is being added to it, must cost you an amount of Ether. Right? Let's go ahead. Now, the Ether has different denominations. You can see the link up there. When you get the slides, you can click on that link. That link tells you the denominations of Ether. Remember how you have denominations in money? You have kobo and naira, right? In dollar, you have cents, dollar. In the UK, you have pound on top of the dollar and all that. That's how you have denominations also in Ether, right? So Ether should be somewhere in the middle here, right? So meaning that we have some smaller denominations after Ether, right? And you have some bigger denominations after Ether. The smallest denomination of Ether is called Wave. So it will cost you some amount of Wave to do a transaction. There's this tool that does the conversion for you when you're writing your program. So my writing program, you now say this function should cost about so and so and another. So that you don't cram all this in your head. There's a converting tool that can help you to do that in relation. So most of the transactions that you see them in relation to Ether. People don't carry this information in their head. So, I missed out the slide. Go ahead and skip the slide. So, rising solidity. Go ahead. Oh, okay. Oh, it's in my pocket. Sorry. Rising solidity. This is where we are going to start going practical. We have a tool that we're going to be using to write solidity. It's online. It's called remix.ethereum.org. Remix.ethereum.org. That's all what it's called. REMIX. You can also Google Remix and you see to take you there. Fine now. So you can Google Remix. Can you see the platform? Yes. Okay, so this is where we're going to be writing our solidity code. It's an online platform that you can use to write your solidity code. How many of us have written a class before? A class. You know what a class is? So a contract is like a class, right? You know, in a class you have a constructor, you have methods in it, and all that. So it's basically almost like the same thing. It's just that the way they do it in solidity is a bit inverted. In most languages, you see something like public, the structure type, and the method name. But in solidity, you will see the structure, the method name, the parameters, and whether it is public or extension. There's a way it does. God help us do this programming languages. But it's fun. All right, so basically we're going to write a small program in solidity. So you can look at my screen. Okay, before we write, let me just explain a bit. So I'm sure when you look at that remix there, you see something like pragma, solidity, something there. Can you see that at all? So every Solidity application has a version that is running with, I'm sure your own is running 0.4 or 24 or 23 or something like that. That's what? So 0. That's what you want to show you. Okay, wow. That's great. Okay. So some browsers will show different versions based on what you're writing, but that's what it comes with by default. Then you have, for example, see this is a small sample code, contract, conditional, and that, and that, and that. Now, when you compile your smart contract, it gives you two things. It gives you an ABI, and it gives you what we call a bytecode. How many of you have worked with an API before? API, you know what an API is? Okay. So look at your API like an API. You know an API, you call it to get some methods and all that, you pass parameters. In layman terms, your API is like your API. Is what your any other application or software will talk to be able to run your contracts. You will not be able to run that contract directly. You can only connect to the API and the method it exposes for you to be able to run the bytecode. So when you compile your Solidity code, it will expose this guy and this guy for you. Right? Does that make sense? So your API is like your API. You know, when you want to consume an API, you see all the documentation and all that, something like that. This guy. So how smart contracts are deployed? So you write your smart contracts, you give it to your compiler. The compiler compiles and shoots out these two guys, basically. So this is like a small holistic picture. Anyway, you get the slides. This is your program. Through your Web3.js, you compile, right? And your DApp pushes the compiled contract to the network. This is your own private one when you're developing, right? But when you push to the test network, it returns, after it has pushed it to compile, it returns the address and the API, right? Then your front end can now make calls to your API. So you can write your front end with React, with Angular, with Vue.js, with any of those things, and you consume your API, right? So it's not something you just grab once and you have to continue reading to understand it, but we're just trying to give you a brief layman understanding of it. So these are the types that you have in Solidity. You have the string, bool, int, uint, fixed, ufixed, and the address. Know the difference between int and uint, fixed and ufixed, right? Unsigned, and then the address. Very key. This is how your address looks like. I'm sure when you look at it in MetaMask, you see something like this. That's your address. Now, the functions you can find in Solidity are public, private, view, and constant. Basically, in some language, I'm sure if you go to some blogs, you see some people using constant, but that will change to view. So just in case you go somewhere and you try to read about some tutorial and they're saying constant and some places that shouldn't view, they are basically the same. They allow you to access information. But anything that has changing of data is payable. You can also use the function name payable. So we're going to do that in a meeting. We're going to see it. I would love us to use a tool, but let's just use a generic tool. This session was supposed to end by 12, but let's see what we can do with the few time we have.
We don't have.
No, we don't have. Okay, processing contract functions. If you call a function, if you're just calling a function, it doesn't cost you money. And you might not necessarily modify the data. But if you're sending a transaction, you modify the data. And at the end of the day, it costs you gas. You return the transaction hash, sorry, not hash, it's hash. This one returns your data, this one returns transaction hash after it has done the transaction. Calling a function runs instantly, but when you're doing a transaction, it takes some amount of time. Calling a function is free to use, but calling a transaction costs money. So when you're building an application in blockchain or in Ethereum, it has to make sense because the users are consuming their money to run your application. Either that or you're building an application that is running off your money, or you're finding a way to get your money back out from the user. So all that now comes to your concept and thinking on how you build your application. So these are the tools we have. I hope you have Node on your system. If you have Node, you need to install Node, although we will not be able to get to that section of using Node on our system. What we're going to do is online. We're going to use Truffle, Ganache. These are tools that we have had to use if we had enough time. MetaMask, we've done that already. IDs like Atom, VS Code, syntax highlighting for your ID, and Remix. So what is Remix? It is an online Solidity ID that is used for writing and testing your smart contracts here. So this is the location and this is the documentation that I put there for you. So for those that didn't get it earlier, you can quickly do that. Don't worry, the slide will be shared to you. As far as bring start online, the slide will be shared to you. Okay, our smart contracts. So let's quickly write one. Remix. It is. All right. Usually you see a default sample app. We can always run this. This one is handling voting and ballots to be precise. Another concept that blockchain is trying to help is trying to eliminate the issues of trust that come up with different applications. So imagine, even before I go forward, let's talk about this. Imagine we have, the voting we're having that just finished in Lagos. The APC, something that happened. Who won again? What's that name? Someone eliminated Ambody. Ambody was on the same Ambo. And they don't want Ambo again. So, okay. So imagine Ambody decides that I'm not sure this, I don't want to. Okay, yes, the big open ballot system, which is, but assuming they were still using that closed ballot system, he might have had to contest that election. But what smart contracts is trying to do is eliminate any ambiguity of trust. Because we can always trace who voted. Not the one that we are saying that you have to go and get your voter's card and all that. Just get your address and come on. And once you vote, it's recorded that Mr. A voted for this candidate. And once you vote once, you can't vote again. you can write your smart contract like that. So this is something like that. You can keep this so that you can also run it and see. But before you can run this, let me show you how some of all these things work. All right, so we're going to create a new file. So go to desktop. I hope we are together. We don't have time to go back, so I hope we are together. Please leave every other thing you're doing. So click on this button here and enter the file name. So I'm going to enter my inbox. Inbox.so. The extension of solidity is .so. So this gives us a blank sheet that we can start with. All right, so let me drop this mic so that we can type. But just help me type pragma solidity. This is yes, pragma solidity. Now, as it's typing, you'll find out that the browser gives you some helpers. So we're going to use version 4.0.4.17. Right? So our contract name is contract inbox. Okay, no, hold it there. Okay, hold it there. So this is our close it. So this is like our class. I'm trying to relate it to those who programmed before so that you can identify or have a relationship with solidity. So contract is like your class. Alright? So you're creating a class called inbox, but here it's called contract. And you know in your class you have some properties, right? So you have your properties, you have your constructor, you might also have some methods inside it. So it's with that concept we're going to build something here. So we want to do an inbox. So an inbox has a message, right? It should have a message. So let's type string public message. Now in other languages, we would have written public string message, right? But in Solidity is the other way around. So they do kind of inversion. String public message. Now I'm going to create a constructor like how Solidity used to work with those versions. But in the new version, they would have called constructor and the name of the class. So in case you see some other older version, I'm going to work with some other versions and I'll still change it to new version and you see how it still works. So just like function inbox, the same name with your inbox there. Open, put in string initial message. So inbox is outside. Function inbox. Inbox is outside. So string message. So that's your constructor. So you can call it message, you can call it initial message. Let's call it initial message. Let's call it initial message. Complete. Initial message. And then we'll now say message is equal to message. Initial. Yes. So we've created our constructor. Right? And what else do you want to do? We want to set that message. So let's create a set message function. Function set message. So it's going to accept something also, string new message public. So message is equal to new message. That's a simple hello world kind of application. Are we done? So, if you notice, you see a warning here. Can you see this warning? It's trying to tell you that we don't do this anymore. This way of programming is we've gone past that, so we'll correct that. But so that in case you are going through some blogs and you are seeing some of these things, you know that you see some of these warnings, you know what they're about. So this guy is blinking. So click on this. Okay, no. Let's go to run. Let's see if it will do that. So now we have what we call the environment up there. You can see it. So click on it so that we can. So we have JavaScript, the VM. That's the environment that can quickly run your stuff on that. The injected Web3 is the Web3 that comes with the MetaMask that you are seeing there. It comes with its own Web3. Remember I mentioned that when you're developing, you connect to a Web3, that's your gateway to the network. And this other one, you specify a Web3 provider. I wish we had more time. Okay, so if you look up here, you can see that your Ether is showing there. That's because it's connecting to your MetaMask. That's the injected Web3. But if we change it to the JVM, it changes, right? So the Remix browser gives you some accounts to play with. So if you click on it, you see like 2 or 3 or 4, there are 5 accounts. They give you some amounts to play with. So you can be playing with the smart contract. So what we're going to do now is that we're going to deploy our smart contracts. All right? See, currently you have no contract instances to interact with. So we're going to deploy to, and take note of, once we deploy, take note of that. So we're going to put an initial message, hello world, right? Put it here in parentheses. I'm going to put that quotes. Yes. Not single quote, double quote. And put hello or whatever you want to put there. Then now hold on. If we're going further than where we are going now, if we're using our local network, this here, if you wanted to test Ring B with an application that you've already deployed on a network, you copy the address and put here, and then it will load that your compiled stuff. So, but we're not doing that. We are compiling this one. And because we are compiling this one, that's why we're going to use the button. So click on deploy. Now you see your deployed contract here. This is your deployed contract. So if you expand this, now you see our 2 functions that we created. The set message, right? By default, what Solidity does for you, I would have done another function get message, but it would have just been a waste of time. Why? Because once you declare an attribute here, Remix and Solidity automatically creates a function for you. So if you click on that message now, just click on message and see what happens. What is you see the string that was initialized, right? So if you now use the other one, set message. Let's just try set message. Put anything. Bye bye. All right, then click on set message. All right, and if you notice, anytime a transaction is going on, something is happening here. This is your debugger. So if there's an error when you was trying to deploy to the network, it will show up there. So now if you click message again, the message should have changed. This is just a simple how to use Solidity. Yeah, and yeah, remember when we deployed, I forgot, we're supposed to look at this guy here to see the number that changed. And for every time we do a set, this guy is changing. Right? There is a, can you go back to the slide? Oh, okay, so not in this slide. But there is a URL. If you Google gas cost in Ethereum, Google gas cost in Ethereum. Gas cost in Ethereum. Scroll down. There's a document that I'm looking for. No. Go back up. I think search for gas cost for manipulations in Ethereum. I need to find that URL. There's a URL that shows all the costs for every line of code. So if you're doing an addition, subtraction, manipulation, conversion, there is a gas cost in it. So I think, let me check my system here. Apologies for that, I couldn't get it on my system, but there is an Excel file for it that shows all the costs. I will send it to you as part of the document I will send to you after the program. But for every transaction that happens in Ethereum, there is a cost. All right. So I've been told I have a very few minutes, and even though I have like 2 or 3 other programs that are not just to do, so probably we'll hold a session like this in the next quarter, hopefully. And in that session, we're not going to talk about blockchain, we're just going to be writing Solidity codes, how to use it with React, how to use it with Vue, and all that. So if you have any questions, let me see if I'm done with the slides. Hold on. Let's see if we're done with the slides. You go through. Okay, yes, we're done with the slides. It's just the workshop. So, questions?
How can you answer questions?
Since there are many corporate miners, what is the chance of a seeing that you're using just one mining machine when there's an organization using a lot of mining machines? So what is your chance as single person?
You know, there's a saying that a pot of soup like crayfish and you spend more. See, the truth about it is that mining is a business. If you want to get into it, just get into it the big way. Look for people who are interested in it and just get it. But if you want to use your own normal system, fine, still doable. If you go to Amazon, there is they have mining machines that you can buy and plug to your network and to be doing small mining there for you and gathering the small coins. Trust me, it still makes money also. But the guys doing this massive thing want to make money. So your system might not be among the first that would find the solution, but it will also serve as a node to store blockchain transactions. Do you understand? So that's just the difference. Any other question?
Thank you, sir. From my experience writing Java program, so one of the things is the use of data types.
Yeah.
So from the set message you have here, I try inputting an integer value there. So and I bring out the message and it gave me without error. It came out without error. So I tried inputting a string now, but without quotation mark, and there's an error. So why is that?
Because when you're writing a program, when you're saying something is a string, what do you do? Don't you put it in quotes?
Yeah. No, but when I put an integer value,
Yes.
there was no error.
What we did was just a simple program. It will just take it at that point in time because we will not put some kind of condition in it. Right? So you just say it as true or false at that point in time. But once you start putting a string that it needs to analyze, it's trouble.
That's the value of the ether. I noticed that it was reduced as we input value inside.
That's what I said.
So why is that?
And somebody else in this class.
Okay,
asked that question.
okay, I get your point now. So what does that say that for every action we take, we are spending? Okay. Thank you.
Anything that changes the state costs you money. All right, somebody else has a question? And some other people. Okay, you have a question.
What I want to ask is just that the solidity. Are we going to be using the online ID?
Okay, like I said, there has been no time. Just ID just for you to be able to do a quick test. It's like, how many of you have used an online editor to run your C# and all this kind of stuff? Just like that. Just an online tool for you to just quickly write. For you to write, to use your Atom, your ES code, you have to have Node.js, you have to have something like Truffle, you have to have Ganache. Ganache is what will give you a local copy of an Ethereum network on your system. So you can now see how it looks like to boost your smart contracts to your system. You will not be able to do that all the time. Any other question?
You want to read it?
Okay. Can the Solidity code be written in the latest version of IS or of JS, like arrow function? Okay, Solidity has its own structure. It has its own way of doing everything. It's not like JS. Don't compare it to any other language. That is way of mapping. That is way of everything. In fact, if we had done the second and third workshop, we will see what we call mapping in Solidity. It has its own way. It doesn't have its own array. It has its own array, but it doesn't have its array.length that we have done in some other languages. So it has its own techniques that you just have to learn. So what we just did today was just a refrap. If we actually want to do something tangible on Solidity, we have to take a whole day. Does writing in Solidity require any rule of thumb? Yes. He has the syntax, he has everything that, just like how every other language has its own way, it has its own rule also.
It's a language.
It's a language on its own. You have to understand it. It's a language on its own. It has its own syntax, it has its own rules, it has its own methods you call and all that. You can put restrictions on the method and all that. You can put validation. But most of the stuff is with the Ethereum network. There are some functions that come free from the Ethereum network, like how you can get the person who is running the function. In Solidity, you can quickly get the owner, like your session ID. You can get something like that in Solidity.
You said something concerning some applications, like for example, Twitter or Instagram. I said it's not advisable to use material because of the cost.
Okay.
So I actually wanted to ask. I think you said Ethereum, that's the price. Is it per transaction or like now? Just browse through the application. I start to pay just browse through without initiating transaction.
Anything like this, anything read on your smart contract does not do any cost. But any write, change of state costs you something. So if I'm doing a Twitter version on Ethereum, for example, and all I'm doing on that application is just I'm just reading people's tweets. Nothing happens. Nothing happens. But the person that is writing the tweets, so you know the kind of person that is tweeting per second.
For example, now, like you have this application, for example, and then you have like, for example, let's use Amazon or Jumia, for example. Like I have to buy from Jumia, for example. So is it that if I'm looking at Jumia's page or Jumia's or Amazon application,
Guys.
I don't think. I don't think. So is it that the guys like how to
the guys are going to Jumia.
not even marketplace, let me just like the marketplace, for example. So me that have my own brand with that marketplace now, I tend to pay.
So, like I said, it still boils down to what I'm saying. You need to find a business logic when you are building your application with blockchain. It's either you say that whatever is going to happen on this on this blockchain environment will be charging me. The creator of the application. Then you find a way of charging, or you expose that cost. As you are using my application, you are being charged. That is now the business decision you have to take. But the fact of it remains that anything that has to change the state on Ethereum network or Bitcoin or any of this blockchain costs money. Okay, there's someone, I think that should be the last person. Okay, I'm you. This other guy was there first.
My question is on blockchain. Like real estate. For instance, if I want to sell, maybe like I'm a vendor now, and I want to sell my house to you. Okay, I don't know if I should say the middleman between two of us is the blockchain, right? So like, how do I bring, as I wanted to give you the picture, how do I bring in this house? As in, I think there should be a form of registration or something.
Okay. It's still what we call smart contracts. You have to build a smart contract to cater for that, right? Put whatever you need to put in the smart contract, whether the person's CFO, all those kind of stuff. It's your logic now that will now determine. Now, when the buyer and the seller has put all that details on the smart contract. The smart contract rule on duty is whoever pays and has paid the required and met all the conditions, hand over ownership to that person. Now, what's happening right now in the real life scenario is that you have a government somewhere. Now, when you sell a land to, you go and update that information, right? But for the blockchain, what the blockchain is saying is that so that somebody somewhere will not go there and say, I'm changing that document. You know, these things happen in almost everywhere, not just Nigeria. So, our government can just wake up one day and just say they're taking over the land. Or somebody can just say that thing that document is invalid. So. But what the blockchain is trying to say is that your own is your own until you move ownership of that property or that thing to somebody else. It cannot be taken away from you. So what the blockchain is trying to give you is trust. It's not that the blockchain will not come and start saying, stop this person from taking over this land. If both of you have agreed that this is our medium to handle this transaction, it cannot be changed. Nobody anywhere can go and change that. That's what the blockchain is about.
Thank you. My question is twofold. So the first part of that, I know there are some other cryptocurrencies that are also based on smart contracts.
Yeah.
So is this Solidity? Is it tied to just Ethereum?
Yes.
So are there other languages specific to write? Like
even on Ethereum, there is Serpent. There is I forgot the name. There are about 3 other languages that you can use to write on Ethereum. But Ethereum is widely documented right now and widely accepted. Just like you having to write, if Eno comes up, like, come up with a new programming language called Enobasi. You will not want to write in that language yet because you will not have any help. If you Google help on it, you will not have. So it's part of what is affecting some of these other languages too. Solidity has been widely accepted. If you search on the problem now on Solidity, you will get some answers. And that's what Stack Overflow helps you to do. So it's not as if these languages are not there, or you cannot come up with your own language. Just they are accepted. Remember I said in the first slide, a committee of people that will accept what you are trying to come up with. Without that committee, because that committee will bring the problems of what your blockchain is having. Somebody else will solve it, somebody else will help another person before you know it gains popularity.
So the second is the concept of gas. So for some kind of applications. So I don't know, I may be wrong, so you have to explain it better. So I know there's an Ethereum network, like where people can buy it at home, like pay for something. And besides even doing smart contracts. Yeah. But now you want to build a blockchain application that's used for voting. And because of the way the smart contracts are written, especially gas to effect on transactions. So I don't expect that you want people, maybe citizens, to pay because they want to vote. So is it that you can build an entire network, blockchain business for offline or separately, or is it still based on the normal network?
That's why I said you just have to come up with an idea that will make it work. But the fundamentals will not change. It's either you're going to be charged for it or the user is going to be charged for it. Somebody must pay.
So that charge, is it because I know to the network is gas?
Yes.
So it doesn't necessarily have to be money now. That's what I'm trying to say. So is it possible because the idea was blockchain because this is it possible to sorry. Is it possible to now say so government specific now we want to create a blockchain to vote in Nigeria? Can we build a blockchain network specifically for voting that mirrors Ethereum technology? Ethereum is open source.
Yes, I'm not.
So when
it will still
require
some amount of money. Why? You need somebody to mine. You need somebody to validate. These guys are not just going to validate for free. So imagine that the government has we've come up with Niger mine. And this mine will do, there is nobody to mine. transactions will just be building forever. You see those people are very good. People will be going this way and nobody is even minding. Thanks. So those are the things that have to be put in place. All right, so we've come to the end of our session. Hopefully, I know this is really crack it for you guys, for the guys that want to go deeper. We will try to do another session where we'll do something hands-on. But at least I'll be able to wait to advertise a bit to be able to know what you can do. So, thank you.
Thank you to everyone that's come. Please give Anna and Lita another round of applause. So as Anna has said, we hope we've been able to convince and not confuse you that blockchain and Ethereum is the way to go. But I just wanted to let you know and get an idea of whether you guys want a follow-up session to this particular workshop. Yes, okay. So I'll include it in the feedback form that you should receive on Monday. So you need data to be able to prove that, please give us money, let us do another workshop. So please indicate your interest for a follow-up workshop when I send you the questionnaire. Also, you get the links to the two landing pages. So for the software development role, so the senior software developer and the fellowship pipeline, so you get those links as well. So if you're interested in either of those pipelines, please register your details in there. If you're not yet interested and you know somebody that is fantastically epic and will be a good fit for Andela, send them the link as well. One of our recruitment team will get back to them. Good? Makes sense? You'd also get the slides as well. So the slides are also already on our Twitter page. So just follow us at Andela Nigeria. Pictures from today will be shared with you as well by the lovely Rachel who shot it. You can find him on Instagram. He's famous, award-winning photographer. So I now invite you guys to have some snacks, food, and ask any questions that you have outside. Just one thing, please stay on this floor. The toilets are once again through those doors on your right-hand side. Please close the toilet when you're done so that the cleaner doesn't kill me on Monday. And thank you guys so much for coming.